right, hello everyone. My name is Timothy Lee Grant, and today we are going to continue our journey through this machine learning PyTorch project. Okay, so last time where we left off, this is where we were. We were trying to figure out like what's even going on. So I have these different scripts that kind of work together. I didn't write any of this. This was Copilot that did it for me. Now I got it to kind of compile, right? So let me show you what that means. Like this, if I do, actually, let me just run one of the models. So I'm going to run this Linet on the MNIST model so I can show you what happens. It's going to work. So haven't touched anything yet. We're just kind of like figuring out what's happening. So I got it to compile. I don't think it's actually doing it correctly. So we're going to have to try to fix like I don't think it's training correctly, and I can talk about why I think that is. But anyways, I'll show you what is happening, and then we can go into even to understand what the model is doing and what the code is doing, because I'm still don't understand that. But anyways, the last video, I got into kind of like the object-oriented programming because I was like, wait, what's happening with this? All right, so here we go. So it comes out with this plot, and you're like, hey, that looks pretty good, right? Like, here's your loss over the epochs, and your loss function goes down. Problem is, though, so me and Susie are actually doing this same project but separately, and then if one of us has a problem, we're able to kind of bounce ideas off of each other. So Susie is experiencing an issue where her training data is following the expected model, okay? But then her testing data, her testing loss looks like this. It's almost an inverse of the training, which means that we're training to our data but not the actual like underlying, we're overfitting our data, right? So that's why I say I have a sneaking suspicion that actually what I implemented here is not correct. But first, before we do that, what Copilot implemented is not correct. But first, before I can fix anything, I need to understand, like, okay, what's even going on, right? Because I don't understand this. So let us continue our journey, and let me minimize myself up here. All right, there we are. Let's continue our journey through this project. Isn't this a fun project? I like this project. Let's just hope I can get it working. It's a cup of coffee. Let's get it. All right, so we have this main. So this is kind of our entry point. We run this train.py and pass in the parameters of the model and the data set which we want to use, okay? Then I think this might be wrong. I think that this is automatically like forcing the Linet model, and that's this one right here. And notice I don't have any of the other models, so I need to implement this. I have this like VGG16. Again, whatever that means, I guess it's just a different model. I have this ResNet18, which also is like a different model. Then we have the Linet again, but on this data set here. Okay, so there's a lot that we need to implement regarding getting the other models and data sets actually working. But right now, I don't even think that this one is working. So that's what we're going to continue to investigate. And that is what I'm going to try to figure out, like, okay, is my training data even accurate to my testing data? So we're going through kind of understanding what the code is in its current state, and then trying to troubleshoot and find the errors with this, and then we can move on to trying to get the other models to work. So anyways, here's kind of where we pass it in. We're doing the train.py, which is here, and we pass in the parameters of the Linnet model and the MNIST dataset. But I don't even think it matters because I just set it as Linnet, like model you are Linnet, okay? So criterion, so in N, this is the neural net, which is part of PyTorch. So PyTorch has different models that you're able to utilize. Now, okay, so I just do cross entropy loss, and I know that this is like a way to, I think that this might be the loss function, okay? I remember a long time ago, I heard cross entropy loss, and I had to do a bunch of statistics about it, but I forgot like what it actually meant, how it was calculated. I forgot all that, but I remember hearing that word, cross entropy loss. Okay. Optimizer. Now, this one I'm not exactly sure what it is. Opt SGD. So opt Optum. Yeah, okay. Optum is also part of PyTorch. So it seems like it's just a different method or library within Torch to be able to perform optimizations, whatever optimizations mean. Okay. So now, great, we have those two things. And now train. Okay, so here's our criterion and here's our optimizer, okay? And then we pass in the model that we want to use to train, and we have the data. So this train loader, I guess let's go and investigate like what train loader is, or this one. So go to definition, and it's going to take us here. All right, so this is one of the other files. So there's datasets, there's test.py, there's train.py, and then there's the shell script. And then also inside of models, I put this Linnet. So we are here in the datasets.py. And as I said, this, when I was doing troubleshooting, this one line of code was like, I was trying to load data from the MNIST model, and I kept getting this like authentication certificate failure, and I had no idea what to do. I eventually just told Copilot, like, because it was telling me like, oh, to fix this, do, and it was giving me a whole bunch of different things that I was like, it's not working. It's still not working. And after like an hour of trying to struggle with that, I finally just said, is there a way to disable the SSL certificates? And it said, put this line of code there. So I did, and it worked. Not sure if that's a good solution, right? Like disabling security features, but you know. Anyways, I'm just trying to get it to work. I'm just trying to understand it right now. Later we can figure out all those strange things. But anyways. Okay, so here's our two models, or two data sets. So CFAR 10, notice that is the same as here. So this is the second data set. And then there's the MNIST data set. So this is to get the data for the MNIST, which is what we're doing in train, right? Yeah, here. And notice this gets called, the getMNIST gets called regardless of the parameters which we passed in. If we passed in this cipher 10, it's still going to just say, no, get the MNIST. So we have not, okay, so yeah, definitely we have not implemented the functionality to be able to actually dynamically select for the parameters which we passed in. So that's something in the future we are going to have to do, but as I said, that's not what I'm really focusing on right now. I'm just focusing on MNIST and Linnet. So for our purposes right now, this works. So, where was I? I was data sets here. So, we're here. We come here and we say, okay, we're going to get the data. Batch size equals 64. Sure. Are we even using batch size? Like, where is batch size? Okay, sure. So, what are we doing? Come on. Transform equals transforms dot compose. So transforms is here. Torch vision. Okay. Compose. And normalizing data. So we're passing in what? We're passing in a list. Okay, we're passing in a list to this transforms compose. What is in this list? The first element is transform to tensor. Okay, so it's a function call and it's just to tensor. Okay. Transforms.normalize. Okay, so I guess maybe this is like setting up parameters. I don't know. And then we're getting the data set which lives inside of the torch vision. And then we're looking for MNest. Then we are storing it in the current working directory and then creating like a data folder, right? So you come here, data. So this is where it's storing things. Train equals true. Download equals true. So I think the download true is kind of just telling it to download the data if we don't have it. And then this should just be like how we want to transform the images, okay? So this is for the training data set. This is for the testing data set. So this is just doing the exact same thing. Oh, that's why we have train equals true, because this is training data. This one is testing data. No wonder. Okay, that makes sense. Then train loader. Okay, so train loader and so train loader is doing what? It is okay, so we're just taking the data set that we obtained. And notice we're not even passing back this train data set. We're not passing back the data set. We're passing back this return. Whatever this returns, that's what we're actually passing back. Okay. So we take this data set and pass it as the data set parameter. We tell it what the batch size is, and then we want to shuffle it. Okay? So now what do I think that this does? Torch, utilities, data loader. Okay. So I'm guessing that what this does is it just takes the data and kind of puts it into the batch size and puts it into like a format that PyTorch can actually use. And then we do that for both the training and the testing data, and then return that back. The other thing that I'm noticing is, look, I'm not even capturing like the test loader, which, okay. So I mentioned at the beginning of this video that I think one of the things that I need to be cautious about is that I think that that graph that was shown is incorrect because that's only the training data. Now, for me to actually implement the testing data, I need to do I need to capture this. So I'm going to just say test. I'm going to say test loader. Okay, we're not using this right now. That's why it's grayed out or darkened. But we will have to in the future. All right. So now we're going to train our data. So we have the model, the train loader, the criterion, and the optimizer. And all of those are passed into this parameter, or this function, which is train. Awesome. Now, what happens? Model. So we have those parameters, and then we also have something called epochs equals 5. Okay, so epochs, I know that is like the number of times that you run the model or something like that. I'm not entirely sure, but that's fine. Okay, so model dot train. Okay, what is this? Model dot train. Okay. Wait, model dot train? Am I calling myself? Model dot train. Go to definition. No definition. Model. Go to definition. Okay. Well, I know that model is equal to this Linnet. And I have here's my init. There is no train function though. Does it like inherit from this in module? That is a question for Copilot. So let me just do this like. Okay. So train.py then linnet.py and I am wondering about the line of code in train.py, and what was it? It was train function. Okay, and then put that in there. Model is in model is okay, how do I ask this question? I am looking at the Linnet object and seeing that there is no train method to call. Okay, it's probably inherited. That's what I'm gonna guess. But let's see what it says. Okay, that's an excellent observation. Model.train call can indeed be a bit confusing if you are only looking at the Linnet class. The train method isn't explicitly defined in the Linnet class because it's inherited from the parent class. Okay, cool. The in module in PyTorch. Okay, so the train method is part of PyTorch's in class, which your Linnet class inherits. When you call model.train, it sets your model to training mode. Oh, okay, so it's just setting like a mode. I thought it was actually performing like the training operations. Um can I go to, I want to see if I can go to this, right? Class module, and now I want to find train. Where would train be? Init. Name. Add module. Okay, let's do a search. So train. Here we go. In, is this part of the in module? It should be, right? The entire thing is module. Okay. What just happened here? So this is, what even is this? All. So I don't even know what this is. So this is a class called module. Okay. And we have this thing called train. Self and T, mode is a Boolean. Set the module in training mode, okay? So that's what it does. Set the module in training mode. This has actually I wanna just close that. Okay. This has any effect only on certain modules. See documentation of particular modules for details of their behavior in training/evaluation mode. If they are affected, class dropout, okay, something or else. Okay, mode bool. Whether to set training mode true or evaluation mode false. So if not instance mode bool raise. Okay, so this is just like an assert. Like if we didn't pass in correct data, something is instance. Mode bool. Okay. Self.training equals mode, which mode is what we passed in. So we're just setting the parameter inside of this module. Okay. For module in self.children. Maybe I don't understand what's going on there. Like, I understand that object-oriented programming is extremely, extremely, extremely important, but I also don't know how to learn it or how to practice because, like, I understand that by the name children, I understand that this is doing something to all of its children, but I don't understand what that means or how to use it or what effect this has. Like, I think it means that it will set this mode for all of the objects which inherit from this class, but if I inherit from this class and then change it from one child, like if two children both inherit from this module, this in module, okay? And I change this one to be training, okay? Does it change this one? Or does it, like, how does that work? I'm not sure. Anyways, and then eval, I guess, is going to probably be the exact opposite of this train. So this is equivalent with Yeah, okay. So self.train, and then we're just passing in false. Okay. So we just call this exact function and say false. We say no, we're not training. Okay. Sure. So we're just setting a mode here. Okay. Then we're creating a list, empty, and then we're probably going to be appending to that list each time we come here. Okay. Then, now, so each epoch we're going to number of epochs. So we just go through like 1 epoch, 2 epochs, 3 epochs, 4, and then stop. Okay. Running loss. So running loss plus equals loss item. Okay. Are we like ever zeroizing this though? Okay, for each epoch we do zeroize it. So, okay, sure. So for image labels in train loader, okay, so remember this is the data which we were obtained from the MNest dataset, which was inside of, like, it's like pre-installed inside of the Torch Vision. Okay, and so apparently we can like unpack it to be images and labels, and we're doing that for every single. Would it be batch size? Would this be batch size? Remember, batch size we said was so possibly what's going on is we have what would this be like? I said we wanted 64 images in each batch. And so what that data loader function did was it took those and created a list or a tensor or a something or other. Okay. So it created that, and each one of those elements has 64 like images. Okay, and then it kept adding another 64 and then another 64 until we reached the end, which the end was like the end of the data set. So possibly what we're going to do is iterate through each of those 64 um each of those 64 elements until we reach the end of our testing. Okay? Now, to verify that, I actually have this image.shape. So let's that was me just talking. That's theory. Let's test out my theory because I don't know if that's actually correct. Okay, so input shape, output shape. Okay. We haven't really looked at output, but I'm not going to look at output right now. Wait, this one is weird because it's the last one. I'm going to look at the middle one. 64. Okay. Haha. That is suspiciously similar to the batch size. 28 by 28, and now this is ringing a bell. I remember 28 by 28, that's the pixels. And then one was something to do with okay. I think this has to do with I'm not sure. But anyways. So there's a list. Okay. So what is the shape? It is torch.size. Wait. So it's stored in like a torch thing. Okay. And there's 64 and 1 and 28 and 28. So I think that this means it is a 1, 2, 3, 4-dimensional vector, right? And so for the first image, so this batch size is 64 images per batch, right? So I can index up to 64, so I can get the third image in this batch size, this image's batch size, right? Because I'm taking the images and I'm looking at it, and I'm seeing that there's 64 of them, so I can index that, and I can just say like the first image, okay? So I'll index 3, and I'm getting the, well, okay, 0 indexed, but I put 3 here as the first parameter, and then I get the fourth image. And then I can, for the fourth image, I know this pixel, I know the specific pixels, okay? Oh, that's what this was, grayscale. Grayscale, that's what it was. And so this value, here we go. So for this is the image that we're looking at, the specific image that we're looking at. This is the specific X pixel. This is the specific Y pixel. And then this is a number between 0 and 1, which represents the like how dark it is. So we can index, so we have each image, and there's 28 by 28. So for each image that we have 28 pixels, and each of those have, each pixel has a corresponding number which is associated with it. That's why there's only one. There's only one number, right? This is one dimension, like one, like there's 64 elements here. That doesn't mean that the number is 64. Like we have to index 64. What it means is we're that there's 64, like that's the length, right? So okay, that makes sense. And I think the reason that this is 32 is just because this is the last thing that we're looking at, and we got 64, 64, 64, 64, and then there was only 32 left. So we just took that and put it in a batch, which, because that's the all that was left. Okay, so actually this kind of is starting to make a lot more sense. Now, so we're iterating through each of those batch sizes. So this is iterating through batch sizes. Cool. Optimizer, 0, grad, good. Optimizer, this was that optim. Okay. Was what, probably stochastic gradient descent. I'm going to guess that that's what SGD means. Okay. Zero grad. Let me just see about this. No definition. I should be able to go here, right? Go to definition. Okay. What are we looking for? We are looking for something that says 0 grad, right? Yeah. Well, optimizer. Okay. Should be a function. Step SDG. So we saw SDG, right? Ooh, that's a lot of parameters right there. Single tensor. Okay. Are you guys seeing the, what did it called? No grad? Like what? Grad is sparse, okay. Let's do a control F. Okay. Zero grad. That's what. Okay. But there's only one. There's only one instance of it right there. So what would that mean? And it's like commented out. So it's probably something that I need to see. I can go to notes. These are all my failed LeetCode problems. Yeah. I have these like JavaScript topics. So in my projects, what I like to do is I work on these projects and then I just take little notes of things that I don't know about and that I won't need to actually look into, like Java topics. Anyways, so let me come here and I'm going to do a new thing, which is, what should I call this? Like, can I rename? Oh, whatever. There we go. Machine learning topics. So we're gonna do, what was it? No grad. Or zero grad, yeah. Like this. There we are. Cool. So that's something that I need to look up, kind of figure out what is going on. Now, let's just come back to here and pretend like we already know it. Okay, so we're just doing some setting. We're setting it. Then we're coming here, and this is what I wrote here because I wanted to figure out why this right here was actually giving me an error. And it was something about like core dump. But then when I put it on my Mac computer, so this line of code failed on my Linux but passes on my Mac for some reason, and I don't know why, but it does. Okay, so what's happening here, I don't know. We need to figure that out. I feel like this is where a lot of the actual heavy lifting actually occurs. So this is something that is important. So remember, images are, that is that vector. It contains all 64 images, and each image has its associated grayscale value between 0 and 1, and for each and every pixel in that photo. Okay, so we're passing that into this model, and then model gives an output. So again, I don't understand. I'm passing in model, which is what? Lynette, right? Like it's this Lynette class. So now, where does model happen, right? Like module. Okay, so I'm going to open this back up. Now, there has to be something which is called what? It should have a function which is called, where did it go? Model. Okay. Lynette, no, modules. So it inherits from here, right? In module, yes. It inherits from here. Now I need to look for something called module. Add module. Or model, sorry, model. Yo, man. Oh, wait, hold on. No, no, never mind. That was modules. I thought I saw model. Hey, here's zero grad. Wait, 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 wait. Ayo. Hold on a second. But zero grad was not on in. Hold on. Okay. Hold on a second. These two are different classes, right? Like this optimizer was this SDG, and now SDG is something completely different. But I'm going to guess that this SDG, and I don't want to do go to definition because then it's going to move me out of this place and then go to somewhere else. But I'm going to guess that it also inherits from in dot module. And if so, here's that function right here. So what does it do? It returns nothing, set to none. Okay, so I'm passing in, I'm calling this function. Okay. So it was true. So it's just saying, okay, we are going to be doing this. So for p in self.parameters, if p.grad is not none, if set to none, which is what we passed in, as true, then we set it to none. So we're just going and changing. Yeah. Okay, so we're just changing the parameters such that all of them are set to grad equals none. So parameter.grad equals none. Okay. So we did not find it. Let us control F and control V, optimizer grad. And there's only one of them, and it's in zero grad, and it's a comment, and I don't like that at all. Hey, wait, no, that's zero grad. I don't. It's not even what I want. And it didn't even, oh, of course it didn't match, because it's not optimizer.zeroGrad, it's just zero grad. So no wonder it doesn't match. I am looking, though, for model, so I'm going to just do model. Okay, I need to be aware of that, make sure that I do things correctly. 1 out of 18. Model. Uh-oh. Uh-oh. It's all comments. Come on. No, that was 8. What, man? How? Modules can contain other modules, allowing nested in them. But this is commented out, though. So delete that. Ooh. There we go. Okay. Anyways, so models is commented out. So I'm gonna come here. I should have probably finished reading this because this is ensures that layers like dropout and batch normalization behave properly. Okay. Anyways, what about the line? I am wondering how and where this model actually lives. Okay, where model is called, and let's break it down. Okay, so where model comes from, the model is initialized in the main function here. Here, LeNet is your custom neural network that is defined in LeNet. Yeah? When you call LeNet, you create an instance of this class. Yeah, so this is just like creating it, right? Okay. So I'm creating the instance. It's stored in model variable. Passing the module. This module variable is passed to the train function. Yep. Inside the train function. In your train function, the model is used to process images in the train loader. Okay? That makes sense? Yep. How does outputs equal... Yeah. Okay. This is kind of the... This is the real part of my question. This is what I'm trying to answer. Let me take a deep breath and try to... Okay, this is what I'm trying to answer right here. When you call outputs equals model images, you are evoking... Oh, we did this last time. This is like that call. This is the dunder call. Yeah! Woo! Wahoo! Yeah, here we go. All right. Okay. So I got excited when I saw that dunder call. I was like, "Oh, I know about this one." But anyways, so method. So in the in module. So I should be looking at this call. Okay. And that's just like, where's the association though between doing the instance? Oh, because I'm calling that class, and because I did not implement like an overriding function within this class, it looks within the module for how to evoke the class. So I'm guessing if I have like, if I do control F and then do my dunder call like this, there it is. Okay. So callable, I don't understand what this means. It's probably going to be my next question, but there it is, right? Like that's what happens. Now I don't understand it. I don't know what that syntax is, but that's what happens. Like this is where it gets called and this is how that operation occurs. Okay. Awesome. Awesome, awesome, awesome. Okay, so let's continue reading though. So, call method. The call method of neural network module internally calls the forward method of your LeNet module. How? How? That's how does it know to call the forward method? How does call know to evoke the forward method inside of my LeNet class? How does it even know that a method exists inside of my Lynette custom class that is called forward? A very reasonable question. All right. But anyways, so this call internally calls the forward method. So somehow this right here, and we're gonna investigate it, calls forward right here. Okay, and passes in parameters maybe. I don't know. Okay, but parameter is x. Now what I'm gonna guess is we passed in images. Okay. And this is going to apply those machine learning kind of operations like ReLU. I know is what an activation function, I think it is. Max pool, I don't know what that is. ReLU again. Max pool, view, ReLU, and then FC, whatever FC is. I remember last video I saw something that said FC, but I can't remember what that was. Oh, here's, wait, but, and we're passing in convolution. Okay, so we need to look at this forward method a little bit more intensely. But first, I want to understand where this call is occurring. So then it goes to the forward method. Okay, we're going to investigate that in a little bit. So model, get more. All right. So the model in the line outputs equals model images in your Lynette instance, which contains all the layers and the forward pass logic. When you pass images to model, it trigger. You know that time when like you're looking at the screen, but your brain isn't working? Like right now, I was reading that, and not a single thought happened in my brain. Like I don't even know what I just read. Anyways, let me try that again. I'm going to take a few breaths, right? All right. The model in the line here is your Lynette instance. That makes sense. Which contains all the layers and the forward pass logic. Okay, that makes sense. It contains all of the logic for the forward pass. Okay. It triggers the forward method of your Lynette class. Okay. Processing, which is here. So it triggers this forward and passes in X, which is the batch of all of those images. There we go. Okay. Processing the images through the various layers to produce the output. Okay, cool. Now my question was, how does the dunder call know to evoke the forward method inside of the Lynette class? Okay. How does it even know that a method exists inside of my Lynette custom class? Because the dunder call is in the neural network dot module, which that is part of Torch, right? Like someone else way, maybe, I don't know, 5 years ago, wrote that portion there. So how do they know that in my function or my class, which I just wrote yesterday, how do they know that there's something called forward? That's my question. What if I called it, I don't know, backwards, right? Like, how do they know that something called forwards? Okay. Excellent question. This ties back to Torch's neural network class. Okay, designed. When you create a custom neural network class such as Linnet and inherit from an in module, PyTorch expects your class to define a for. Oh, so it's just like that's the way that the in module is written, that it expects that your custom class has a forward. And then what I'm going to guess is that in module, this one has a forward method in it that is kind of the default forward method if you don't implement anything, right? But then because I implemented mine here, it kind of overwrites the parents. So let me kind of test that theory. So I'm gonna go forward. Oh, there's a lot right there. Can I just do this? Slow forward, self.forward inputs. Okay. Slow forward, register forward. Okay. I don't necessarily know if that's true. But anyways, I think what I was saying was correct about the fact that it's uh like it just expects that you overwrite a forward. Anyways, so let's keep reading. Mechanism behind the magic. Okay, let me get back to the Dunder. Oof. Wait, hold on a second. Hold on. Wait, why is this? Oh, this is wrapped hook. This is not even the module. This is wrapped hook, and wrapped hook has some kind of call as well, so I can evoke that. Okay, anyways, whatever. Magic or mechanism behind the magic. Inheritance and call method. Your custom Linnet inherits from an in module. An in module defines call. Yes, it does. It's right here. Okay. Which is used to make instances callable like functions. Yep, that's why I was so confused. Why last video I was saying like, wait, why am I able to evoke an object? It's not a function. There. There it is. That's as Copilot says, that's the magic. All right. Okay, man. This is something, huh? Neural network module defines call method, which is okay, I just read that. When call is evoked, it internally calls the forward method on your specific class. Awesome. Expectations of a forward method. PyTorch's in module is designed with the assumption that any subclass will implement a forward method. Okay, so that's just an assumption that you will implement this forward method. When you define Linnet and inherit from an in, it looks for a forward method in your Linnet class. Calling forward method. The call method manages the execution and calls the forward method from your class, passing in the input tensor. Okay. So it says, if you see here class module, and then it says the def dunder call, and it has star input and double star kwargs, okay? And then it just does self dot forward. So return self dot forward. So it's evoking forward. So can you do self on the child though? That doesn't make much sense. And this is not the format that we see here. So those are two questions. Okay. Why it works when you evoke this, it triggers Linnet instance dot call. Okay. Which then calls Linnet instance forward. Okay, so it's something about the instance. So there's something with instance here that I think allows me to use this self and then dot forward because it's of that instance or something. Okay, so but that's another interesting thing that I need to remember to investigate because that's important, I feel. Specifically for understanding how object-oriented programming works, and as I said at the maybe halfway point of this video, I was something that I really want to learn is, okay, how do you actually do object-oriented programming? How do you, that's something I really need to, I really want to understand because right now that's definitely a gap in my knowledge and I want to pursue that. So, okay, that's something I need to put in my head. Don't forget instance. Okay. Designing contract by inheriting from an in module, you're agreeing to implement the forward method. Okay. Dynamic lookup. When call is executed, Python's method resolution order, Myro, okay, ensures it finds your forward method in your class. Okay, cool. Okay. Now, in your implementation of call, it looks very different from the one I am seeing in my module for the can you explain what I am seeing in mine? Yeah, that's what it says. Okay. Wrapped call implicit. Okay. Okay. Absolutely. Let's clarify. What you're seeing in PyTorch NN module implementation. The line in question. Yes, this is. You have been called for questioning, Mr. Dunder call, colon, callable, list of triple dots and comma any, and you're equal to underscore wrapped call. You're under question. Okay. So, explanation. Dunder call, callable. Okay. This part is a type annotation. It tells you that call is a callable function, meaning you can call it like object. That can take any number of arguments. Okay, that's what this triple dot is. I think like C has this as well. You have to use that triple dots for like printf, for example. Because if you think about it with printf, how do you know how many arguments you're going to be given, right? You don't really know because they could do like %d, 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 %f, %d, %d, and then have 1,000% d's, and you don't want to write a function and okay, if they pass in 2% d's, do this. If they print or have 5% d's, do that. If they do 5% d's and 1% x, do this, right? Like you don't want that. So you can use this like triple dot to represent any number of arguments, and then you are able to like go through each of those arguments and just say like, okay, take the while your arguments are not null, essentially, whatever, you're able to loop through and say, okay, if it's an X, do this. If it's a D, do that. If it's an F, do this. If it's a LD, do this, right? Like based off what parameters they put in, and however many they put in, just accept it. So that's kind of that triple dot. All right. So callable is imported from. It's just like a class or something else. Okay. Wrapped call implicit. This is a reference to the actual function that will be called when you use call. Okay, so PyTorch's in module uses wrapped call implicit to wrap the call to the forward method, adding additional functionality such as hooks and preprocessing. Oh my goodness. Okay. Oh. Okay. Oh, all right, man. So, without driving too deep into the source code, it does the following preprocessing. Okay. I'm gonna write down about the in your implementation of dunder call, it appears okay. Where did they do the call? Here we go. Copy that whole thing. Okay. It appears that I am able to access or call the method of a child using the self, but doesn't self refer to the in.module class, not the child. Okay. You're on the right track. Let's clarify the concept. In Python, self is a reference to the instance of the class itself, the actual object in memory. When you inherit from in module, self refers to the instance of the subclass. Like, oh, that, okay, then that makes sense. Okay, it's not the module self, it is the Lynette class. Okay, I think I understand. Should probably read through that, but my brain is a little bit. Okay. So, you're on the right track. How self works in inheritance. Oh man, come on. I can make it through. I can make it through. So base class has self.forward. Okay, cool. Now child class, okay, has inherits from base, yeah. Instance, child, okay. Result of instance of 3. This calls instance callable, okay. Oh, so I'm creating a child instance. Okay, that makes sense. Okay. Now I'm passing in 3 as the parameter. And now 3 comes in here as one of the arguments, and it goes to forward, and it passes in 3, right? And then, okay, so I think I'm understanding. Okay, I think I understand. All All right, so cool. We got to the point where I understand how I can evoke this, and it is doing this forward method, but we don't know quite what the forward method is. Um, and I need to look up, like, I need to investigate, like, what's actually going on here. So, I think what I'm going to do is I'm going to stop the video here and I'm going to take a little bit of a break. I'm going to do, I'm kind of hungry, so I'll probably have dinner. So I'm going to take a little bit of a break, give my mind some time to rest a little bit because I also just got off of work. So I woke up, whatever, like 6 o'clock in the morning, went to work, did work, came home, then immediately came on, turned on my camera, and started investigating this neural network stuff. So I'm a little bit hungry. My brain's also a little bit like, oh, come on. So I'm gonna give it a little bit of a break. And then come back, and I'm planning on doing another video today. So I'm gonna do two neural network videos today. So I will see you guys in a few hours. So anyways, thank you for watching this video. I hope you enjoyed it. My name is Timothy Lee Grant, and I will see you guys in a few hours, and we're gonna investigate this forward method. Don't you guys love this? This is so fun. This is really fun. Like, I don't know, every time I'm looking at it, I'm like, the more I'm looking at it, the more I'm interested in it. And I'm learning so many interesting concepts. Like, think about how important object oriented programming is, and all of this inheritance stuff, and all of this that, as you can see, like, I'm very, as I said, like with my YouTube channel, I'm trying to provide an honest and uh, accurate depiction of, like, yeah, I don't know everything. I'm not this super genius that I'm trying to just pretend like how smart I am. Like, I don't know these concepts, right? And I'm going to be honest about that. And it's okay to not know something, but then figure it out, like the phrase that I said yesterday was stupid for 5 minutes, or stupid for 10 minutes, smart for the rest of your life. I like that idea. If you don't ask, you're smart for 10 minutes and then dumb for the rest of your life. So, this is super important. I'm really happy that I'm able to come in contact with these concepts and really wrestle with them and try to improve myself. So, anyways, I am going to be back in a few hours, and I will see you guys then. All right, bye.